Hi guys, welcome to Piece of Code and welcome to this video. So in this video we're going to learn about solid principles, which is a very important I would say concept in system design or low level design. So basically, if someone asks you in an interview or anytime, if someone asks you what do you mean by solid principles, you can just answer like by using solid principles you can write better code, right? Or you can just say you can write code following the best practices or adhering to the best practices. That's it. You don't have to give a bookish answer or any kind of hi-fi answer, because that's what it is. That's what it states, the solid principles, that you should write better, efficient, reusable and compact code, and it is one of the most important features of object oriented programming or programming in general, right? Now let's see how does it help us to write good code and how does it plays a very important role in system design or in low level design. So let's first list down all of the principles that we need to see, and then see one by one what is each principle and what does it teach us. So I'm just gonna write solid over here, and let's list the principles down. So S stands for single responsibility principle. O stands for open close principle. L stands for Liskov. I'm not sure about the spelling, I think it's this only, Liskov Substitution principle. I stands for interface segregation principle, and D stands for dependency injection principle, and commonly it is known as DIP. And this word you would hear a lot in Spring framework or Spring Boot framework. Whoever are using this Java backend, who are Java developers, they will understand a little bit more. Even Angular front-end developers will also understand this dependency injection principle as well. Okay, so let's see one by one what does it thing means. So let's talk about this first one, which is known as S, which is single responsibility principle. So the single responsibility principle, in terms of simple words, it states that you do one thing perfectly. That's it. That's what it states in real world scenarios. For example, a lawyer, a doctor, an engineer, they should do what they are best at. They should not do multiple jobs, right? It doesn't mean that they cannot do. Just understand the crux of the statement. It doesn't mean that they cannot do, but they should do what they do best. They should have only single responsibility which they perform best. So if you're going to talk in terms of classes and all, you should know that one class should have only one responsibility. Like I said, one person, whatever the profession is, should have that responsibility to do. Now, if you are going to see a coding example, you will understand it a little bit better in terms of programming. If you see, I have created over here called solid a package, and under that I have created all these principles sub packages. So first let us see this single responsibility principle, and I have created two classes over here. One is single responsibility principle violation. Here you will see how you violate the principle and don't follow it, and then you rectify it and actually follow the principle. Now if you see, if you're going to violate the principle, this is how it works. So I have a class inside another class, which is completely normal, it's fine. So let's focus on this invoice class over here. Now if you see this invoice class over here, it has multiple methods which perform different operations. One method performs calculate the total invoice amount, for example. Second method prints the invoice, and third method saves it to a store, like a file system or database, wherever you want to store. Now this particular class is doing three things at once, this invoice class, which is not at all the principle that we just discussed, which is single responsibility. It has multiple responsibilities. So if you're going to rectify that, you just divide it into multiple classes. So this class invoice is only going to be bothered about calculating the total. The invoice printer will print the invoice, and the invoice saver class will save it to the store or the file system, wherever. So this is what single responsibility principle means. Pretty simple to understand. You don't have to mug it up to remember this, and it's pretty simple. Now one thing I want to say that, guys, as you move forward down this line, right, so it will be like if you are learning single responsibility principle, then open close principle becomes a little bit easier to learn, because it kind of correlates with each other. Once you learn this, then this Liskov substitution principle becomes easier. When you learn this becomes easier, like that. So you can relate all the principles with each other, and then you learn, and then you'll be able to understand what exactly does each principle means. Right? Now we are done with the single responsibility principle. Pretty simple to understand. We had a very good start. Now let's move on to open close principle, guys. Open close principle. So open close principle states that if you have a class over here, it is performing some operation, right? It has some behavior or an operation. You should not modify the existing operation that it has, or existing function or existing behavior it has. Instead, what you do, you extend that class and extend an additional feature if you want to add. For example, you have a class A, right? You extend it to a subclass B and add maybe another behavior or operation. But you should not modify the same operation that is present in the class, because that makes sense, right? Every time you want to update something, you can go, if you go to the same method and update it like every time, like 100 times, 1000 times, it becomes a very cumbersome job. Instead of that, you extend that functionality. If you already know that, okay, this has an extensible functionality and I can extend it in the future, better you create a subclass or an implementation or a new implementation inside another subclass or another extension. I hope that is making sense. Now if you see in terms of coding, I'm going to show you a very simple code example. So this is the violation. How do you violate this thing? Basically, you have one class known as area calculator, and it has a method known as calculate shape area. It accepts a parameter of shape type, which is an interface that I have created. So the circle is of a shape type, and also this rectangle is also of a shape type, because they implement shape. Pretty simple to understand. Normal inheritance or in implementation mechanism, right? Now what this method does is, based on the instance it receives, like if it is a circle instance, then we are calculating the area of the circle. If it is a rectangle instance, then we are calculating the area of the rectangle. Now if I want to add another shape over here, for example a square, then we have to add another else if condition, and we have to add another instance of condition over here, and then we have to calculate the area of the square. Here we are violating the open close principle, because we are not extending the functionality of this particular class. Instead of that, we are modifying the operation which it already has, this particular behavior or the function it already has, right? This is not what this open close principle states. So if you want to rectify that, so you create the interface shape with a class known as calculate area. Now you create a class circle and you implement shape, you extend that particular interface or implement in this case, and you override the calculate area method with the logic of the circle area. Then you create another class called as rectangle, you implement the shape, and then you override the same method with a different logic to calculate the area of the rectangle. So here you are extending the functionality instead of modifying what you already have. Now in the future, if I want to add multiple shapes, I just implement the shape interface and then add its implementation of the calculate area method. So it is very easy. Then we have this area calculator class over here, and in this method we accept any shape, whatever shape you add, you don't have to touch this area calculator method, and you just call the method calculate area, which is basically calculates the area of that particular shape and returns the answer, right? I hope that is making sense. So this is open close principle, guys, where you extend instead of modifying the same behavior or the function of the particular class. Alright, so let's move on. I hope this is clear. If you have any questions, you can put it down in the chats, right? Now the next is Liskov substitution principle. It's a very interesting principle because it is very easy to understand. If you understand it in a very easier manner, it's very easy actually. So Liskov substitution principle is based on a very simple fact, where a parent, if you are assigning a child class object to a parent, so parent p equals to new child, for example, right? And then this, using this reference, I call any function of child, for example fun. Now this child can be anything. Now for example, let's assume this parent has multiple children, child 1, child 2, child 3, child 4. Now what Liskov substitution principle says, that you can replace this particular object with C1, C2, C3, C4, whatever children objects you can replace over here. This is just an example. It doesn't mean you have to do exactly that. Okay, it can be a parameter, like a function parameter, where you accept a parent p, and inside that function you perform some operation, for example p dot fun, right? This is just an example because I wanted to show you that this is the implicit casting that we do over here. Anyways, so what I'm trying to say is, you can replace this object with any child objects that you want of that particular class, parent class, and any operation that I perform should not break. It should work. So what does this should not break means? Let's see it by an example. So I'm gonna just go to my IntelliJ and just see this LSP violation class. I'll just gonna open this LSP violation class. So we have a vehicle over here. This is a parent class, you can say. So a car is a vehicle and a bicycle is also a vehicle, right? So we have inside the vehicle I have a start engine class, and it says engine started, some println statement, pretty simple. Then we have class car and it extends vehicle. It has to implement the start engine method, obviously, right? Then we have a bicycle class. Now if you see this logically, a cycle doesn't have an engine. I have created this example based on real life example. A cycle doesn't have engine, but it has to implement the start engine method because it is extending vehicle, right? Now this is true in the case of interfaces or abstract classes, but this is a concrete class. But anyways, just assume that you have to always implement this start engine method. So as a cycle cannot have an engine, this method can throw an exception saying that unsupported operation exception. So whenever, for example, in some for example in the main class, you try to create the object of you can say, for example, vehicle v equals to new bicycle. Okay, this is throwing an error because I must make this static so that it will be able to access in a static method. All right. So as we have used this class inside this LSP violation class, this will be treated as members. So if you want to access a static inside if you want to access inside a static method, you have to make the member as well static. That's pretty simple static terminology. Anyways, so if you do vehicle v equals to new bicycle, now if I call the v dot start engine method over here, this will fail because it will break, because it will throw a unsupported operation exception. So you don't want to have this in your code where you are dependent a lot on this this parent object holding the child objects, and sometimes the code breaks because some child object will throw an exception or an error stating that this is not supported, or this is not a very actual or a factual implementation, right? That's where it violates the Liskov substitution principle. Now if you go to the if you see this class, how to rectify this. So here if you see in this vehicle interface, we have only one method which is called move, and we have another interface which says engine powered vehicle, and it is extending from vehicle, right? And it has a method called as start engine. Now what will happen is that whatever vehicles which have an engine can implement this engine power vehicle, which is of type vehicle. So a vehicle this reference can hold any of its child objects. That is still holding true. So any engine powered vehicle will implement this engine powered vehicle interface, and for example the cycle, which is not an engine powered vehicle, can directly implement vehicle and can implement the move method, and the other engine powered vehicle like a car or a bus, whatever, can implement the start engine as well as the move method. I hope that is making sense. So that is about Liskov substitution principle, where subtypes whatever you have must be substitute for their base types, which is parent types, right? I hope that is making sense. Now let us move on to the next principle. We are done with 3 of them. Let's go to interface segregation principle. Now what does interface segregation principle says that any client means whoever uses it, right? Whatever class it uses it. Any client should not be forced to depend on methods it does not use. This is a very bookish definition. Let's simple it out a little bit. So let's try to understand this thing. When we talk about a mobile phone, what is the basic use case of a mobile phone? The basic use case of a mobile phone is just to call and maximum to text someone. But basically the telephone, or the main telephone which was in the olden days, was used just to call. All these features that you see now, these are not the base features of a phone. This messaging, so this music, movies, games, whatever you see. So if I want to create a phone, I don't have to have all these features. I just need to have the ability to call and to message. I don't want to have any other unnecessary things that are not that much of a requirement in a phone. Means obviously nowadays it's a very much of a bigger requirement because we are very much of addicted towards phones, but that's a different thing. So let's understand by using an example. So if I go to ISP, and if you see, I'm going to go to ISP violation, and here is an example of a printer. Same thing, you can create a phone over here, and here I'm going to take an example of a printer, and it says all-in-one printer. So void print. So nowadays printers have also a lot of features. Printers can print, printers can scan, and printers can fax as well. But what if I want to have just a simple printer? So if I want to have a simple printer, class printer or simple printer, if I have to implement this all-in-one printer, right, then if you see, I have to also implement the methods, all the methods of the all-in-one printer, which I do not need. The scan and this fax methods are not needed in this case because I just need the ability to print, right? So these are unnecessary methods that I have to implement. So this is what interface segregation principle says. Please do not have methods, and don't force your subtypes or your clients to use those methods. Instead, you create specific interfaces and direct your clients or your subtypes to use those specific interfaces for their specific use cases. So if you see the ISP over here, I have a interface printer which has having only one method, print. I have a scanner which is having only one method, scan, and I have a fax which only has one method called as fax. Now if I want to create a simple printer where I just want to print something, I will just override the print method of the printer because it has only one print method. Now if I want to create a multifunction printer or all-in-one printer, I can implement three of these things: the printer, the scanner, and the fax. That's how, if you see nowadays phones. So previously, if you see, in mobile phones we had a separate mobile phone, we had a separate radio, and we had a separate you can say music system. So we combined all of those things and made a smartphone. That's a simple example of what interface segregation means. So you have specific interfaces, you can implement any of those interfaces and combine their behaviors to create a new behavior, but don't force or predetermine that okay, all these behaviors I need beforehand. Okay, I hope that is making sense. That is what interface segregation principle dictates. Now this is very much of linked with this LSP that we just saw, Liskov Substitution principle, where we saw that any parent type should be able to hold the child. Here also, if you see, you don't want to have any method in your subtype which breaks your code. Instead of that, if you make specific interfaces and make your subtypes or your clients implement those specific interfaces, then there is no chance of your code to break, because you are very specific to a use case. I hope that is making sense. So try to relate it with other principles as well. You will find a lot of common things and will help you to understand the concept better. Okay, last but not the least, what do you mean by a dependency injection? Now previously what used to happen is that let's talk about a specific example, in a real world example. So when you learn to drive a car, a manual car for example, right, when you learn to drive a what car, a manual car. Now it doesn't mean that you can only drive a car of a single brand. For example, you can only drive a Audi or a Tata car, or I don't know, Mercedes, right? So when you learn to drive a manual car, you can drive the manual cars of all these brands or manufacturers, right? You are not specifically learning for a single car. So if you are injecting a dependency to, I mean here it's a dependency, you are learning to drive a car, that is a dependency to drive a car. So you cannot inject a specific, if you just inject a specific dependency of driving just the Audi car, then you cannot drive the other cars. Those are still kind of manual cars, a little bit different, but still they are type of manual cars, right? That's what I'm trying to say. Here the dependency injection principle says the same thing. Let's see it by an example, you would understand it better. So if you go over here, DIP violation class we have, DIP violation class. Okay, so I have an application where I want a MySQL database. So what I do is a simple thing is that I create a MySQL database over here, right, and I have a connect method to connect to my database, and I directly put the concrete class of my MySQL database. This is a concrete class, right? So I directly put it as a member over here, and then I directly create the object of that MySQL database. So this is a concrete implementation, and then I do whatever I want with my database. Now this is fine if you have a single database that you work with and you don't want to change your databases. This is absolutely fine, nobody will say you anything. But what happens if you need another database, or you change from this MySQL database, for example, to a PostgreSQL database, which is still kind of a SQL database? So you have to create another class PostgreSQL, whatever the database name is, and then inside that you will create one connect method, and then you have to inject that dependency as well over here, right? You have to remove this and you have to inject the PostgreSQL database dependency. So this is what dependency injection tells you to avoid. It tells you to avoid the concrete dependency injection. Instead of that, what it suggests is to have an abstract dependency. So what do I mean by that is, you create one interface database. Now you insert this abstract, this is abstract only, right, because it's an interface. You inject this abstract dependency into your whatever class you need. Now what is the advantage of that is, now if I want a MySQL database, I will just implement the database. So as database is the parent class, it can easily accept any object of MySQL database. So you can inject any database as a dependency. Now I have a MySQL database. Now if I want to create a PostgreSQL database, I will just do this. That's it. And I don't have to change anything in the application, because this database will accept any kind of a database which implements the database interface. Simple as that, right? So that is what dependency injection says, that you don't actually, depend on the concrete implementation. Instead of that, you should be dependent on the abstractions, so that you can easily, it will provide you with a lot of flexibility, and you can easily replace the objects, the child objects, right? And it completely makes sense. And you can see this a lot in Spring, where you actually auto wire, you use this auto wire annotation to auto wire a dependency in your class. And generally what we auto wire is not the concrete class. Instead of that, we auto wire the parent abstracted class, like a service or a repository, right? Now this annotation is not working because this is obviously a normal Java project, not a Spring Boot project or a Spring project. But whoever have the experience in Spring Boot, they will be able to understand. If you don't even have, that is fine. This is like the first step to understand dependency injection in Spring, because this particular thing is automatically taken care by Spring. You don't have to create the object or anything. Okay, that is how it works. Dependency injection, where you inject the abstraction, you are dependent on the abstraction instead of the actual concrete object. So very simple to understand, and it's very, very useful. So yeah, that is all about the solid principle, guys, and I try to make it as simple as possible, and not much definitions and all those things, because this is very, very important in terms of interview. Lot of people ask it, and lot of people don't be able to answer to this particular question, because either they forget about the concepts that you have learned, or they are not able to provide a very convincing example. They get confused. So always try to relate it to real life objects, guys. It will help you a lot, and it will help you to understand the concept a little bit better. Okay, so that's it from my side for this particular lecture, guys. We'll meet in the next lecture. Till then, have a nice day, take care, and bye bye.